If you're a software developer right now, you've probably noticed something interesting happening. Job postings that used to say a backend developer or full stack engineer are now asking for things like LLMs, RAG systems, vector databases, AI integrations. Something is clearly shifting, and the role that keeps popping up is this one: AI engineer. Now, when you search for how to become an AI engineer, the advice is kind of terrible. You either get these giant roadmaps with 50 different tools, or you're told you need to spend years studying machine learning theory before you can build anything. For most developers, neither of those paths make sense. So in this video, I want to give you a realistic roadmap for transitioning into AI engineering, what you actually need to learn, what you can skip, and what the job market really looks like right now. Okay, so what is an AI engineer actually? And before we talk about learning paths, let's be clear about what people actually mean when they say AI engineer, because that title gets used in a lot of different ways. A machine learning engineer usually trains models from scratch. They work with data sets, model architecture, math, and it's a real role. But that's not what most companies mean today when they want to hire an AI engineer. What they usually want is someone who builds applications powered by existing models. You're not training GPT, you're not inventing a new transformer architecture. You're using models like OpenAI's GPT, Claude, Llama, whatever fits your use case, and you're building real products around them. Things like chatbots that actually remember and understand context, search systems that understand meaning, not just keywords, apps that summarize documents, generate content, analyze data. The core skill here is not machine learning theory. It's knowing how to take these models and plug them into real software systems that solve real problems. Okay, the job market reality. Let me be very direct about the current job market reality for AI engineering. It's competitive, really competitive. A lot of developers saw this shift early and started learning months ago. Entry-level AI roles now get hundreds of applications, and companies are looking for people who have already shipped AI features to production. I'm not saying this to scare you, I'm saying it because the advice that says you'll be job ready in 4 weeks is just not true. The people getting hired right now usually have a few things in common. They build real projects, not just demos. They can explain why they made certain decisions. They understand where these systems break, not only what they can do, and they have proof that they can ship working software. That's the bar right now. So as we go through the roadmap, keep that in mind. The goal is not collecting tools, ticking checkboxes, and getting certificates. It's to become someone who can actually build. Now, let's start with the foundation you need before anything AI specific even matters. If you're already a software developer, this part should feel familiar. First, be comfortable with JavaScript or Python. Most AI tooling use them, and you don't need to be amazing at these. You just need to know your way around the ecosystem, packages, project structure. Next is API work. You'll be calling external APIs constantly. LLM providers, embedding services, vector databases. That means learning about rate limits, retries, failures. If you've done integrations before, you should already have this covered. You also need basic data understanding, JSON, text parsing, cleaning documents. Nothing fancy here, but just don't be afraid of data. What you can skip for now is the heavy theory, statistics, linear algebra, deep neural network internals. Interesting stuff, useful later, but not required to start building. Now, we get into the core skills that actually define AI engineering today. This is where things start to feel different from normal backend or front-end work. The first big one is prompt engineering, and I don't mean clever tricks or trying to jailbreak ChatGPT. I mean, learning how to get reliable outputs in a production setting, how you structure prompts, how you use system messages, how you give examples when the model struggles, how you handle cases where the model does something weird or unexpected, and that'll happen a lot. Prompting feels easy until you try to make it work consistently. The difference between a cool demo and a usable product is many times just prompt quality. Next, you need to know how to work with LLM APIs. Pick one provider: OpenAI, Anthropic, Google. It doesn't really matter. Learn how requests work, how streaming works, how context window works, how costs add up faster than you expect. Tools like the Vercel AI SDK with OpenRouter makes it easier to switch models, and this matters because the best model for your use case might not be the first one you use. Once you're comfortable there, this is where one of the most important patterns come in: RAG systems. RAG stands for Retrieval Augmented Generation, and it's one of the most practically useful patterns in AI engineering right now. LLMs don't know your data. They have knowledge cutoffs. They don't know your internal docs, your users, or your business context. So instead of fine-tuning a model with all your information, you retrieve relevant documents at query time and include them in your prompts. To do that, you need embeddings. That's how you turn text into vectors that represent meaning. You need a vector database like Pinecone, Weaviate, pgvector. Pick one. You need chunking strategies. How you split documents matters way more than people expect. And you need retrieval logic. How you decide which chunks actually get sent to the model. On paper, RAG sounds simple, but in practice, small mistakes can kill quality. Bad chunking, wrong embedding model, too much context, not enough context. These are things you only learn by building and breaking systems. The last core skill here is evaluation. This is critical, and it's where a lot of tutorials stop. LLM outputs are probabilistic, so traditional testing doesn't really apply here. You need evaluation datasets, metrics that actually matter for your use case, ways to catch regressions when you change prompts or models. If you skip this, your system will slowly get worse, and you would know why. Okay, for phase 3, the production skills. LLMs fail in strange ways. They hallucinate, they misunderstand inputs, they ignore instructions. You have to expect that and design for it. Costs matter too. Token usage can add up fast, so you need caching, cheaper modules when possible, and systems that don't melt your budget. So, how do you actually learn AI engineering without getting overwhelmed? Here's my honest advice. Don't start with a course, start with a project. Build something you actually want to exist, something useful, something annoying that you wish worked better. You'll hit walls immediately, and that's good. Each wall tells you exactly what to learn next. Learn that one thing, apply it, keep going. After 1 or 2 real projects, then courses can make sense if you want. Because when you use them, then you know why things matter. If you can, build in public as well. Share what you're learning, share what breaks. That creates proof of skill and sometimes opens doors you don't expect. And if you want extra signal, contribute to open source AI tooling. Even small contributions show you can work with real code bases. Okay, so how do you actually stand out in the AI engineering job market if it's so competitive? Real projects, that is the key, not toy demos. Being able to explain why you made certain choices, knowing when not to use AI, and having depth in something specific. AI engineering is broad. Go deep in one area, even if you want to have knowledge about so many other things. Have this area that you know very well. RAG systems, agents, voice AI, a specific domain. It's much easier to be skilled in something deeply than to have a vague idea of everything. Also, remember that not every relevant role is called AI engineer. Backend roles, product roles, developer relations roles at AI companies all use the same skill. So what's the big takeaway here? The path from software developer to AI engineer is more accessible than ever. The tooling is better, the patterns are clearer, the resources are everywhere, but it's still real work. You have to build real things and actually understand what you're doing, even if your title never changes, because these skills are becoming part of modern software development. So start building something this week. Start building something today. You learn more from one real project than from 10 more videos, including this one. So if this helped, please subscribe to this channel. It genuinely helps more people find these videos. And please leave a comment as well. It tells the YouTube algorithm that this is what it should show to other developers. If you want to go deeper into one of the most underrated AI skills, learn how to ask questions. Check out my book, The Art of Asking Better Questions for Humans and AI. It's about understanding how models think, how to frame problems clearly, and how to get the specific results you want, not just from AI, but from people too. Links are in the description. Thank you for watching. Now, go build something. Seriously.